value creator. So if you see the chemical industry worldwide, it creates value. The right-hand side graph, if you see, even in India, our chemical industry, the total return to the shareholders is much higher even compared to the global chemical industry. It's a consistent value creator. And last 2-3 decades, China has really emerged as a manufacturing hub as far as chemical industry is concerned. You can see the numbers; they're leading in the production of chemicals in the globe today. Now, if you look into Indian chemical industry, we are not a very big player globally, but the to Indian economy, the criticality of chemical industry is very high. It is very, very important for as far as the export is concerned, and also the application of chemicals in India. It's very important. We're just 3% of the world, and our estimated turnover is around $160 billion in 2017. But it is a very, very vital industry if we really want to continue to support the civilization the way it is.
One second.
Further going into Indian
Connecting the
chemical
charger
industry,
first.
if you look into the
Working with
exports
setup.
and imports
Yeah.
of chemicals in
Okay.
India, exports
Total
of
orders
chemical in India.
dispatched in 5 days. This
Hello.
so yeah, we wanted to do basically orders and shipment.
I request
Basically,
everybody
I
to
put
put
5 and
their
3,
mic on mute. Hello.
and this is the orders.
Hello. Yeah. If we look into the export and import, we are like number 3 as far as export from India is concerned. Chemicals is number 3, 9%, and it is at number 3 position in India. And import also we are at number 4, 9% import is done. So what is important here is the gap between export and import of chemicals. It's a $15 billion gap between the export of chemical and import of chemical. It means we are huge quantity of chemicals are really imported in India. This means there is a huge opportunity for having a growth of chemical industry in India, because we are really importing and the demand for chemicals is very high. And if we further break down what are the chemicals where there is a huge import, petrochemicals really stand out. We import very large quantity of petrochemicals, and my next slide shows list of chemicals. If we can just attend to these chemicals which are listed in this particular slide, we can really bring down the import almost by $11 billion. So these are the C1 chemicals, which may be methanol, formic acid, acetic acid, or acetate esters, EVA, PVA. We import very large quantity, you can see. Then we go to C2 chemical, which is ethylene dichloride, vinyl monomer, and also PVC. PVC we use very large quantity, but we still import. We have got 3-4 big players in PVC in India, but still we import a lot of PVC from abroad. Similarly, than styrene, we don't have any big player who is producing styrene in India. So this is produced. Then styrene and then related polystyrene, ABS, SAN, and SBR. SBR we have got 2-3 plants. Reliance has 1 plant, but still the import of these chemicals is very high. Then we can further go down to phenol and phenol related products like polycarbonate, MMA, PMMA. Here also we are importing. And acrylic acid, oxalcohols, and acrylates. This is huge. We don't have any acrylic acid production plant. Only BPCL has announced in Kochi when it may come after a few years. And then, of course, PO, PT, polyol, polyurethane systems. Here also, most of the chemicals are imported. So if we can really focus on these chemicals, production in India, then there is a big possibility to reduce the import and bridge that gap between export and import. So this means we are talking about Atmanirbhar Bharat in chemicals. Let's say these are the areas in which we need to really focus, put into chemical industry, and also these are the areas in which new technologies have to be invented, innovated, and then we start putting it. There is a big opportunity for all scientists and engineers also to develop technology which can be better than the existing technology, which are more greener technology, with less CO2, which are more dependent on renewable feedstocks. There's a huge opportunity because India needs this. If you really look, demand is growing for all these chemicals, but we are largely importing. So there's a needs to be a big initiative in this particular area where I have focused largely on petrochemical, but this same thing will be there for other chemical also. Now, this particular slide, if you see, most of the chemicals, the first three chemicals, we are almost have nil presence in the export, global export in electronics, plastic additives, food additives, nutraceuticals, rubber chemicals, flavors and fragrance, we have got some presence. But otherwise, except for API intermediates, agrochemicals, dyes and pigments, our share in the global market is very small. You can just compare with China. China has got, let's say, API intermediates 11% share, we have got 4%. Agrochemicals, China has 17%, we have 6%. Dyes and pigments, we have 5%, China is 12%. Plastic additives, we have 1%, China is 8%. Electronic chemicals, 22% China share, and India is only 0.02. So this means, again, there is a huge opportunities to get into other chemicals also. But immediate, if you want to get fast increase our share, I think we have penetrated into API intermediates in the world, agrochemicals and dyes and pigments, and to some extent flavors and fragrances. I think these are the industries to be supported with the technology, with the better technology from R&D scientists, and also from government through its policies, so that we can have a bigger share, global share as far as these areas are concerned, and then start building capability and competencies in other chemicals also. Now, I come to this particular concept, like here, oil field chemicals is very related your oil and gas upstream industry. Just I have one data here. You people are more knowledgeable than me. Asia Pacific oil field chemical, you can see the China is 50% share. And we're very small here also, less than 10% share in the market. It means even oil field chemical, which will fall, I think, under specialty chemicals, we also have a huge potential to grow and develop new technologies and as well as also become Atmanirbhar and make India a leader in this area. That was one point, that there is a huge potential for chemical industry. You take any chemical sector, there is a huge potential. Only will and determination is required, backed with proper technology, proper policy. I think India can be a major manufacturing hub in some of those. The second point which I want to do is, we have just heard from Vilas Tavdeji, there is going to be energy shift. We have given a very big canvas of possible energy options available to us. So this is a reality. Most likely this is going to happen, because if you see this particular slide which I am showing, by 2050, if the way we are living today, like business as usual, what is going to happen? If our population will be 9.1 billion, GDP will be somewhere around $280, and then of course life will go up to 75. And our energy, if energy source remains crude oil or natural gas, we will require very large amount of this natural gas and crude oil to really meet the energy demand. Then what problem we are going to face is, we are going to have CO2 concentration in the atmosphere more than 550 ppm. So this particular scenario is unsustainable. If we keep on living the way we are doing, if we keep on using the energy options which we are presently using, that is largely based on fossil fuel, the world is not going to be sustainable. How to make it sustainable? The very large percentage of energy has to come from renewable, which don't produce carbon dioxide. So we may have some percentage of fossil fuel still by 2050, but very large number of energy has to come, so that we can keep carbon dioxide to less than 450. Then only it can be sustainable. That means carbon-free energy option has to be implemented for keeping the world sustainable. This is a reality which everybody is talking. And what are the options? What are the options which are available to our country or to the world for energy? People talk about hydrogen, which is little away. We talk about electric vehicle, and we have heard electric vehicle energy has its own problem because we still produce most of our electric energy from coal, fuel cell, battery, solar, wind, biomass. Some of them will be implemented in new next few years. We'll see they becoming more and more commercially used. Some of them are long term, like hydrogen may be long term option as far as energy is concerned. Now, if these happen, let's say by 15 years from now, our chairman also said he is going to decarbonize our whole Reliance industry. It means we are also going to go away from fossil fuel to some other form of energy. Now, what does it mean to the world? If we really go to some other form of energy, like let's say the transportation sector is the one where the maximum fossil fuel consumption happens, and number of vehicle on the globe today is we have very large, almost 1.2 billion vehicles are there on the globe, going very fast also. If this shifts to, let's say, electric vehicle, batteries and fuel cell hydrogen run vehicle, then carbon dioxide emission is likely to come down. But then the need of gasoline, diesel will reduce substantially. If you don't really need gasoline and diesel from refineries, so what is going to happen to refineries? So immediate impact we are going to see is the disappearance of gasoline and diesel from refineries. It means we have to find some better use or some other use of gasoline or diesel, maybe gasoline or diesel based petrochemical industry, because the availability of gasoline and diesel will be there in the refining. That is one impact. So what is now estimated, next few years, India is going to add more refining because we still need energy. It's not that we have an alternative energy option available to us. We'll need energy, so we are going to expand our refinery capacity. But post 2030, some of the old refineries which are uncompetitive will really dismantle. And by 2040, we are going to shift most of our refinery will shift to petrochemical. And presently, we are producing 12 to 20% petrochemicals, any refinery. Future, it will be 75 to 80% petrochemical, maybe 20% will be only the fuels, maybe largely aviation fuel, and some cases other fuels also will be. So there is going to be huge impact on refining sector next 15 years, which is very clearly seen, and we have to be prepared for that. And more or less, almost all companies in the world which are in refining business, they are adjusting to this. Even Reliance is in adjusting to this particular scenario. But we have to go a little up to oil and gas exploration. If our refining crude or the fossil fuel consumption is going to go down in the world, and we are only going to convert crude to petrochemical, the demand of crude is also, or need of the crude in the world also will go down. It means it is going to have impact on even exploration industry. It means we don't need to produce that much oil because energy is going to come from some other source which is not fossil fuel based, and we'll need only crude for producing petrochemicals. We need carbon for producing large amount of petrochemicals, polymers, fibers, all sorts of petrochemicals. So your overall exploration industry also is going to be impacted. This is a real scenario, and we should start thinking. If refining people already have started thinking, they are going to adjust maybe 15, 20 years from now. But exploration industry also has to start thinking, if we don't need to produce that much crude, then the requirement of what will be the real scenario by 2040, what is the real scenario by 2030 for this crude production from exploration, and what type of chemicals, oil field chemical really will be required by that time. I think that type of thinking, that type of dialogue has to start now, so that particularly industry doesn't die suddenly. Industry can make correction right now, start making correction, and then can shift to the new scenario by the time this happens. That is another very important point which I thought I should share with you. Now, next point is the next third point which I want to share with you is, we should really work very hard now, as we have shown you that most of the chemicals in India we are importing. We are the largest importers of chemicals. You can see the gap is huge, $15 billion. how to we really start chemical industry along with some of the very highly professional, competent scientists, engineers, how to bridge this gap and really approach to the government that this needs to be done. Now, for oil field chemicals, I'm not highly knowledgeable. I only know little bit about oil field chemicals, but I picked up one example where I think there's a huge potential, possibility to become really self-sufficient in India, and technology is not very complicated. What is required is only some decision and some determination to make. That is what is this. I'll talk about organoclay. No, drilling fluids, we know in all of you, most of the people who are attending this conference know about drilling fluids. What is their function principally? What type of drilling fluids, and use oil-based drilling fluid, water-based drilling fluid, and we also know drilling fluids needs a lot of additives, solid phase, liquid phase, and they also need clay minerals and also some viscosity modifiers. And one of the vital additive is the viscophiles. That's why I have picked up this organoclay. Now here you see we are very large. I'll show you the number. India is very rich in clays minerals, particularly Western India, Rajasthan and Gujarat combined together. We are very rich in colonite. We are very rich in bentonite mines. Very good quality of bentonite is available in Rajasthan. We also have some reserves for this satellite. These are the chemicals which are used for oil drilling, and as such, somewhere we are using the combination of these minerals as such. In some cases, we use them after modification. So 1970, for this modification of rheology of the drilling fluid, organoclay was the one which started getting implemented and found its good market. Now 1980s, people shifted a little to the polymer also, but the polymers have their problem. One is the cost, and second is the thermal stability. That's why in 21st century, the nanoclays, which are nothing but organoclay, where the size of the particles of the clay platelets is really controlled. So they are in nano dimension size, less than like 100 nanometer, 1 nanometer thick and 100 nanometer long. This you can create the particles of this nanoclays. So nanotechnology came, and now of course next generation people are talking about synthetic magnesium carbonate based also. This is the structure of the clay. We normally use this Mont-Blanc type clays for this making organoclays, which is having two tetrahedral, and in between is the aluminum octahedral. Now this is the one sheet of the clay, and there is a gap between the two. It is very easy to separate these layers of the clays, which is TOT, we call tetrahedral, octahedral, tetrahedral. Then there is a gap in which the exchangeable cations goes, water goes, and then there will be another particle like TOT. And now it is very easy to put organic cation in between the interstitial space of these two TOT species. And then if we put a very large cation into, these two get separated and they really become nanoparticles. And this technology is not very complicated. That's why I'm showing what one has to do. We have to take a natural clay from the mines. We have to do beneficiation, which are very well established technologies available. Then making organoclays or nanoclays from this is simple cation exchange process. You have to use this very large, like stearic acid, quarterly ammonium salts of stearic acid, oleic acids. Like here I have shown hexadecyl trimethyl ammonium bromide, and a few things we have shown. If you can use organic, you can also use phosphonium if you want high temperature. This is simple cation exchange process. What will happen between the layer of the two clay, this organic moiety goes and sits, and then it becomes organoclay nanoclays. Now this is not a complicated technology, and we have got, and then this particular organoclay nanoclay is not only useful for as a viscophiles for this drilling fluids, it also finds its application in multiple situations. It can be used in cosmetics, it can be used in grease for grease formation. It also really goes in polymer, nanocomposite of polymer as a reinforcing agent. and you can develop a very good thermally stable or even higher mechanical property, better barrier property of the polymer if you can really put nanocomposite of this nanoclays with the polymer. So there is a huge market for this. Now, still, I'll tell you why I am presenting particularly the non-polar. We don't have really any big company which is producing organoclays and nanoclays. Whatever is being produced in very small scale level in India. In fact, India has got a potential to be the world leader in this case because of this number. If you see, we have huge deposits. We have got almost 100 million tons deposits in Rajasthan, Barmer area, and 90 million tons in Rajasthan bentonites. Now, what we have to do is only to make nanoclays, organoclays from this raw material. Presently, lot of these clays are exported, and we may be importing organoclays or nanoclays. Now, this reverse, this shift has to happen because technology is not very complicated, and we have got very large deposits of the raw material within the country. So that's where I think we have to put our brain. I have just given one component of drilling fluid. Similarly, we can pick the other component of drilling fluid and start thinking where is the opportunity to make world leader in particular. At least if we can become even world leader in some of these chemicals, I think that also will mean a lot to the country. And that's why I thought I should pick up this particular example. So I think with this I will end. I have just made 3 points during my presentation to this audience. One is that chemical industry is very significant in India, and present state, if you see, there are huge opportunities because we need a lot of chemicals because of a large population, huge growing middle class, and there's a big gap we are importing. And there is also big opportunity to develop better technologies for making petrochemicals because of environmental awareness today and better technologies available. And also India has got the right requisite competency in research and technology, engineering. We have got huge bandwidth in this area. There's a big opportunity, and we need to sustain chemical industry because it's very vital to the growth of the country. Second is this: we really need to think through next 20 years refining. What will happen to refining? How it is going to adjust to the major global energy shift which is happening in the world, and also what is going to happen to all the upstream exploration industries or upstream related industry, maybe oil field chemicals or other, how they are going to adjust because the requirement of this crude definitely is going to go down if one major user of fossil fuel is disappears from the globe. That is also needs to be thought about. Third is I have shown that we have to pick up some chemicals where India is strong in raw material and we are good having some technology and start really working on that and become the world leader. So these are the 3 points I thought I will share with you. With this, I really thank organizers for having invited me, Professor Bij and Pandeyji, and also Jyoti and Nikhil, who really followed it very well. I'm really glad. And if there is any question, you can write to me. My email is there, and I'll be very happy to answer that. Thank you very much.
Thank you very much, sir.